When we look at the average web page, it usually has a few images on it, and those images take some time to download. Now, there's often some pretty good opportunity to optimize this. Let's mash on that.
Hi everybody, and welcome to another episode of the Asp.Net Monsters. In today's episode, we are going to revisit why using bitmaps on your web page is a bad idea.
Ooh, bitmaps, yes. So fortunately, we've moved past that. So
Images, some of us have.
I would say most websites are hopefully not serving up bitmaps, but we're using some slightly more modern image format, like a JPEG or a PNG that offers some level of compression, right? So that image, instead of being every single pixel, it's compressed into something that is reasonably quite a bit smaller. But there's some new image formats out there. So let's take a look at, I just have a really simple website here that just displays an image, and we're going to run some page load performance tools against it to have a look at what it tells us. So this is my HTML, really simple HTML. It's just displaying the single monkeywall.jpg. I have a very simple CSS that's just saying that image is going to be with 100% height auto. That's it. That's my whole page. In order to run this, to run the testing tools against this, I need to be running a web server for it. So I'm just going to load that up and navigate to my page here. So here's my page. That's it. It's just this single image, such WebP, which we're not using yet. So simply just JPEG. And the tool that I've been using a fair bit lately is this Lighthouse Tool. You can run this publicly on your websites if you go to Page Speed Insights and point it at your URL. But I'm just going to run this report, and it's going to do some testing. Oh, I'm going to cancel that. I actually want to run the desktop version of this first. So we're going to focus on desktop initially. So it's running a series of tests against this, and it gives me a performance score of 82. And
it seems pretty good.
Yeah, I mean, it would get me a degree in university. It's a pass at least, sort of. But the first thing it points out to me here is that it's saying serve images in next-gen formats. And it's telling me there's a potential savings of 1.48 seconds, which is pretty substantial. It's telling me the page would load that much faster, a second and a half faster, and this is all just running it locally, second and a half faster if I converted to WebP. And it's telling me that that image, which is currently like 3.7 megs, could be 1.8 kilobytes. Or 1.8 megs instead. So like a pretty substantial savings in the image size. So let's talk about WebP a little and what it is and where it's supported. And then we'll look at how we can convert this image to WebP and see how it affects our page load speed. So WebP is pretty universally supported. If you take a look at can I use, it's not supported in IE 11, but IE 11 isn't really supported anymore, so we shouldn't really have to care about that. The one outlier that's a bit of an issue for me, at least, in the websites that I'm supporting is Mac OS prior to Big Sur. So if you're running Safari on Mac OS and you haven't updated to Big Sur yet, you don't have WebP support. So if that makes up a substantial portion of your traffic to your website, you may still need to provide a fallback mechanism. But fortunately, that's easy enough to do. So we can still provide a WebP image and then have an automatic fallback for the browsers that don't support it yet. And that doesn't really cost us a whole lot in terms of added effort or like overhead on the application itself. So there's lots of ways you can take an image and convert it to WebP. There's a bunch of websites you can use. You could have what's that tool that Photoshop, PowerPoint, Photoshop to convert to WebP. That's kind of a heavyweight tool. What I've done is I've created just a really simple Node.js app here to do that, and I'm pulling down two packages, ImageMin and ImageMim-WebP. There's also CLI versions of this tooling. There's lots of different ways you could do this. But this is how I chose to do it. So I have just a function here called resize image. I give it my image name and where I want to output the folder. and then I give it an array of target widths because I may want to resize it later on. So initially I'm just going to resize it to the exact size that it used to be. And then I just call this image min, giving it an image and some configuration here. So we have this image min WebP plugin that we're using. We give it a quality, how we want to resize it, and the method. The method here is you can opt to do it faster, but it's not going to do as good a job in terms of like how much it compresses the file. I don't really care if it takes me a little bit longer to compress it, so I go to the slowest option that's going to give me the smallest file. That's method 6. And then quality is something that you can kind of play around with. It depends a lot on your image. For some images, if you do a quality level of 80, it's 0 to 100 for the quality. If you go 80, you might start to see a few artifacts in there. A lot of images, it's fine. Things like screenshots, I find sometimes I need to bump that up a little higher to like 95 to make sure those artifacts don't start to appear. But 80 gives you a nice, really small file, which is kind of the default that I start with. So I'm just telling it, I have my images.monkeywall here. That's the JPEG in that folder. I'm just telling it, go and resize that image. And I'm just going to use the original size. The image was originally 3,998 wide, so that many pixels wide. And then I'm just going to do node, just to run this here in my console. I'll do node image minimizer.js, and it'll run for a little bit, and it's going to compress that image for me, or convert it rather to WebP. So now I have this WebP image here. I've added the image width to it. You'll see in the next episode why I'm doing that, because we're going to play around a little bit with responsive images. But you can see that the image itself looks the same as the other one did.
Yeah, that's pretty good.
I mean, looks fine to me as an initial pass, but what happened with the image sizes here? Let's have a look. So when I look at images, so we went from 3.7 megabytes to 1.3. So even smaller than Lighthouse suggested, and that's because I used that quality setting of 80. If I bumped it up to 100, I suspect it would be that 1.8 megs. Okay, so how do we go and use that in our app now? Well, the easy thing would be to just say -398.webp. I could do that, and it would work fine here in my browser. When I refresh this and I look here, now it's using that WebP image. But we want to specify that fallback. So there's something that's been around for quite some time in the browser called the picture element. And what you do is you wrap your image in a picture element, like so. And I'm going to give this, move this one back to the original JPEG here. But then I'm going to give it a set of sources. And with the source, I give it a source set. So this is where I'm going to specify my WebP version. And then I give it a type. Images type isn't the right thing, is it? What am I trying to do here? Yeah, type image/WebP. I was expecting some autocomplete there that didn't happen for some reason. All right, so we have our source. We tell it the type is WebP. So what the browser is going to do then is, if it supports WebP, it's going to say, oh, for the image inside this picture element, I actually want to use this one. I'm going to download this one instead of that bloated JPEG. But if I don't support WebP, I'm just going to use the original one. So that means that Safari on those older versions of macOS is going to fall back just fine. And even IE would actually fall back just fine. It we wouldn't have a broken image link in there. So let's go have a look at what that looks like now. Still just renders exactly the same. If I inspect, I should see that the actual image that is loaded there, if I just go open a new tab, you can see that it was in fact using the WebP version here, not the JPEG. But let's go see what this does to our Lighthouse score. So we were at 82. It was taking 3.3 seconds for the largest content paint, which was the big image. So let's go and rerun that now.
Ooh.
Now we're getting a score of 97. which is great. And we can see that rule that was previously failing has passed. It's moved down into here. The serve images in next-gen format. There's no longer any savings that it's finding there that we could take advantage of. And now the next piece to this, the next piece to optimizing this, is that the image that we're displaying here is way bigger than it really needs to be. It's at 3,000 or 3.5 megabytes in size because it's 3,998 pixels wide. It's just more than we need. So what we're going to do in the next episode is we're going to take this one step further, and we're going to look at how we can use those source sets to supply a set of images at different sizes so the browser can decide which one to download, what makes the most sense in terms of the expected width of the image when it gets rendered. Excellent.
Well, I'm super excited for that. This is being interesting. I don't know that I've ever used that picture element, but I'm also going to need to start doing that. So thanks, Dave, and thanks everybody out there for joining us on today's episode of the ASP.NET Monsters. Remember to like, comment, and share, and we'll see everybody next week.
Bye.